Okay, if we look at 1, when you guys fill out, all right, for this, you guys should have gotten that negative 3 squared is going to give you positive 9. Then you get positive 4, 1, 0, 1, 4, and then 9. All right, so when you graph that, you're going to get that shape. So you get that regular parabola shape. Next one, when you graph x cubed, if you do negative 3 times negative 3 times negative 3, you should get negative 27. Then you get negative 8, negative 1, 0, 1, 8, 27. So when you plot that one, you get something that looks like this. Okay, next one, when you do C, what do you guys get as your first one? Because I really don't know. Negative 81? What? And then negative 16, right? Yeah. Negative 1, 0, negative 1, negative 16. Shh, y'all be quiet. Negative 81. So you get something that looks like, so if you raise anything to an even exponent, you're going to get a positive number. So negative 3 times negative 3 times negative 3 times negative 3, that's a positive number, and it wants the opposite of that, so that's how you get negative 81. And then the last one, what do you get for the first one? 243. And then 1, 0, negative 1, negative 32, and negative 243. So that one ends up looking like that. Okay, so on here, this is your even side. These are the ones that have even exponents. So A and C is your even side. This is your odd side. So if you go to number 2, it says talk about the symmetry of each graph. So if you look at the even side, you would say that both of those are symmetric across which axis? Which axis can you fold it over and it hits it on the other side? Your y-axis. All right, so if you cut it in half right through the y-axis, you hit your graph on the other side. So even functions are symmetric across your y-axis. So if you fold it in half over that y-axis, then you hit it on the other side. Now, if you look at your odd functions, are your odd functions symmetric over either axis? If you fold it in the y-axis, do you hit it on the other side? No. If you fold it over the x-axis, do you hit it on the other side? No, but they're both centered around your origin, and if you took it around your origin and you rotated it 180 degrees, you'd hit it on the other side. So odd functions are symmetric across the origin. Is that going to fit? Across. The easiest way to remember that is odd and origin both start with an O, so that one's pretty easy to remember. And then the next thing is end behavior. So you guys haven't learned end behavior before, but I think that end behavior is a really easy idea. It's just the writing it that sometimes confuses people. So if we go back up to A, all right, the way that you're going to write end behavior is like this. You're going to say, as x approaches infinity, that means as you go towards the right, because as x approaches infinity, you're going to the right of your graph. Y approaches, and then you need to tell me, is it positive infinity or negative infinity? So as we go to the right of this graph, we're going up, 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 up. So if we're going up forever, we're going towards positive infinity. So that's how, this is what would be called right end behavior, because this is what's happening on the right side. So then if we were going to do left side, we would say as x approaches negative infinity, so as we go to the left, because all your negative numbers are on the left, what's your y doing? Well, as we go to the left of our graph, we're still going up, 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 up. So it's going to be as x approaches negative infinity, y approaches positive infinity still, because it's going up in both directions. This is your left end behavior. The only thing that's going to change from question to question is this right here. It's always going to say as x approaches infinity, y approaches something. As x approaches negative infinity, y approaches something. You're just filling in what's happening with y, because you're always going to go left and right. So I want you guys to try to do B.
2.
No, 1B. So as x approaches infinity, y approaches what? As x approaches negative infinity, y approaches what?
Oh, I put B. No, fine.
So that's like your basic setup. That's what they'll all look like. You're just filling in what happens for y. All right, so as x approaches infinity, as we go to the right, does y approach positive infinity or negative infinity? Positive infinity, because it goes up. So as we go to the right, our graph's going up, so that's going towards positive infinity. As x approaches negative infinity, as we go to the left of our graph, y approaches what? Negative infinity, because it's going down. So that would be your end behavior for that second one. Okay, if we went down to D and then we'll go back to C, if you did as x approaches infinity, that means as I go to the right, because again, positive numbers are on the right side of your graph. Y approaches, as we go to the right, this graph is going down and down and down, so it's going to approach negative infinity. As x approaches negative infinity, y approaches, as we go to the left of our graph, our y is going up, 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 so y is approaching positive infinity. So this would be your answer if you were asked, what is the end behavior of graph B? You would say it like that. And in question 3, it has how you would like write it out. So if you have to do it on a test and you can't do the arrows and the infinity signs, you can just write it out the way it says. As x increases positively, y increases positively, or you can say whatever you want to say. And then for C, y'all go ahead and write C real quick. So take like 15 seconds and y'all try to write C. All right, so on this one, you should say that y approaches what for both? They're both going to approach what? Negative infinity, because they go down both directions. Okay, now 4 is going to be the big one. So we're going to make kind of like a little chart for 4. Make sure everyone got that one. Okay, so on 4, the easiest way, so it says make a conjecture about end behavior and odd degrees and even degrees and all that stuff. So the easiest way is we're going to draw like a little 2x2 box because you only have 4 options. Okay, this is going to be your even column. So if you have an even function, this is going to be your odd column. So if you have an odd function, this is going to be your positive row, and this is going to be your negative row. Okay, and this is going to be true for every single one. So if you have an even positive, that's like part A. If you have an even positive, it is going to go up to the left. It's going to go up to the right. You don't know what's going to happen in the middle, but it's going to go up left and go up right. If you have an odd positive, that's like B, it's going to go down to the left, but it's going to go up to the right. Even negative, that's like C, it's going to go down to the left, down to the right. And then odd negative is going to go up to the left, down to the right. So when we get to the other side, you're going to look for your leading term. Your leading term is your biggest term, the biggest exponent that you have. And you're going to follow this chart right here. So I'm going to let you finish filling it out if you haven't, and then we're going to flip to the other side. You get it? Okay. Okay, so on number 5, it says that you have negative x cubed. Actually, on number 5, let's go through and circle what your leading term would be. So look for your biggest exponent. That's going to be your leading term, whether it's the first one, second one, or third one. So like this is the only term. So that's obviously, this whole thing is my leading term. Has to be the biggest exponent you see. If they write it in like a good order, it should be the first one, but sometimes it's not. So for B, this should be your leading term. Biggest exponent. For C, that should be your leading term. And then what about for D? Which one is it? First one or second? Second, with that negative. So you want to, this whole thing is your leading term. Now, using that idea and using the chart that we just made, you're going to think, okay, this is negative and this is odd. Negative and odd is going to look like this on this side and this on that side. It's going to go up to the left. It's going to go down to the right. Then you can fill in what your end behavior is. You can say, okay, as x approaches negative infinity, and you can write it in either order. You can do the positive one first or the negative one. So that means as I go to the left, my y approaches positive infinity. Because on the left side, this left arrow is going up. And then I would say, as x approaches positive infinity, as I go to the right, this arrow is going down. So this is going to be that y approaches negative infinity. And that would be your end behavior. So try to use that chart from the last page, fill out what your arrows should look like, and then try to write the end behavior that goes with it. So this next one, it's positive and odd. So you should think, okay, it's going to go down to the left. It's going to go up to the right. So that's kind of what your arrows should look like that you're thinking about. And then you're trying to fill out what that end behavior would be. Okay, so that's what you guys should have gotten for B. Your next one on C, you're saying, okay, that's a positive and it's even. So positive and even should be going up in both directions. So as we go to the left, your y is going down, so it's going to negative infinity. As you go to the right, your y is still going down, so it's still going towards negative infinity. Oh, I'm lying to you. These are both positive. Oops. Positive, positive. And then the last one is where you have a negative and you have even, so this one's going down in both directions. So this should be, as x approaches negative infinity, your y also approaches negative infinity because it's going down. As x approaches positive infinity, your y is still going down towards negative infinity. So you can see all those. You can use that leading coefficient test for every single polynomial function. And that is something that's just nice to know because it gives you an idea of what your graph looks like right off the bat. We're not going to do 6 because your conjecture is right, because it was my conjecture mostly, and that is it. This one's just talking about how changing your x value. So if you have an even function and you have f of negative x, think about if you have negative 2 versus positive 2, when you square that, you still get the same number. So it's like taking it and reflecting it, but you still hit it on the other side. So nothing would change here. Versus odd functions, the shape changed completely. But those are the big